In section 1.3, we're going to talk about simplifying radicals and expressions involving rational exponents. So the first thing that I would encourage you to do is to memorize some of the perfect squares and perfect cubes. And that way it'll help us to be able to simplify radical expressions with numerical radicands pretty easily. Okay, so the first thing is to take a look at a square root of a perfect square. You know, the square root of 25, for instance, the radical is this symbol. The radicand is the expression under the radical, and the index is whatever the root is. And so in this case, it's a square root. We don't have to write a little 2 here, but we could. If it were a cube root, there would be a little 3 or 4th root, etc. But what we're looking for is if the radicand is a perfect square, then we know that the answer is a rational number. In this case, just 5. Well, so some of these properties, if x and y are greater than 0, then the square root of x times y is the same thing as the square root of x times the square root of y. And so the square root of 4 times 9 can be broken up into the square root of 4 and then times the square root of 9. And we can see that that would be square root of 36. And then the square root of 4 is 2, and the square root of 9 is 3. And that is the same outcome, which is just 6. The square root of x over y is equal to the square root of x divided by the square root of y. For instance, the square root of 9/4 can be broken up into the square root of 9 over the square root of 4, or 3/2. If you have just the square root of a perfect square, the result is, as long as x is positive, the result is just x. So square root of x squared is just x, and that's kind of the same thing that applied to the square root of 25, which is 5. The square root of x cubed is x times the square root of x. Okay, so a numerical example of that, square root of 125 is the square root of 5 cubed. Okay, so how can we simplify that? X in this case is 5, so we have 1 5 on the outside, and then 1 5 left under the radical. Now the reason why we can do that, and we'll do that throughout this lesson, is 125 is the product of a perfect square, 25, and another factor of 5. So 25 times 5. And then we can rewrite the square root of 125 as the square root of 25 times 5. And using this first property, that becomes the square root of 25 times the square root of 5, and thus we get 5 square root of 5. Now, the cube root of x cubed is just x, so the cube root of 125 is just 5, and then this last expression, x to the a over b. X to the a over b is actually the same thing as the bth root of x to the a, and that can also be written with the a on the outside of the radical instead. So an example of this is 5 to the 3/2. Okay, that is going to be rewritten as the square root. The 2 gives us the index of the radical. The square root of 5 to the 3rd. Okay, that's one option. The square root of 5 and then to the 3rd, that's another option. And then you can simplify from there and write it in simplest radical form. And so we would end up again with 5 square root of 5.